Video we will be talking about popular interview questions. So we will be discussing quite a few popular interview questions. So this is our ninth video. So let's get started with the first question. So let me type question one. So this is our first question where we need to identify the output of this expression. That is question one.js. So what do you say? What will be the output for 5 divided by 2? So it will be 2.5 because the number will be converted into a floating point number. So this will give us 2.5 and type of f will be number, right? Type of a where the content is 2.5, right? So this is our first question, right? So it was a pretty easy one. So let's go with the next question. We what will be the output for this one? So take a guess, and I will write the output right now. So this will be object, right? It's a bug in JavaScript. It's a bug in JavaScript, right? So type of null will give us object. So right, this is the second question. Question number 3 is what will be the output for this and what will be the output for this and this one. So first one would be true since both are empty. Null is, so basically there will be type coercion, same, the both will be converted into the same type and they're holding nothing, so that is why this will give us true. And this one is a strict comparison, second statement, so this will give us false. Null equal to null will give us true. Nan equal to nan will give us false because the nan, not a number, can be can be generated from a variety of ways. Like if you divide by 0, that will be not defined. If you do operation like undefined plus some number, so that will also be nan. So it could generate from multiple sources. So that is why not it is not equal to nan. Nan is not equal to nan, right? So this was our third question. Question number 4 is this. Question 4.js. So guess the output for this. If we call console.log fn1, what will be the output? Will it be my name is Khan or something else? Since we have basically hit enter and written this in another line, JavaScript will think that we are returning we are not returning anything, so by default it will give us undefined. JavaScript compiler will say that, hey, this is if you're entering it into a new line, I will assume that this is like this, it is like this, so return. So by default it returns undefined, so that is why the output for this would be undefined. Right, so this will give us undefined. This will give us 2.5. Right, so now let's move on to the next question, that is this question number 5. So what will be the output for this? If we call the real function, what will be the output? So in the memory allocation phase, the memory is allocated to real, firstly this function, then this will be overridden, then this will be overridden. So output would be you both are wasted. So basically there will be a hoisting that will happen and the function will get this memory reference where this will be console.log we both are wasted. So this will be the output. Output would be you both are wasted. Right, so let's move on to the next question. Next question is this. So if we write cap dot say hi, and we are calling this say hi function, and it is referring this dot first name. So cap say hi is called via cap. So this will be an object, and object is having the first name as Steve. So this will be Steve. And say hi if say, and now we are basically storing the reference of the say hi function in say hi add, and we are simply calling say hi. So it will be like window dot say hi. So basically the this will point to the window object, and in the window there is first name defined as Loki, so it will be Loki, right? So Steve and Loki would be the output. Okay, it is giving me undefined. Steve and undefined. That doesn't make any sense. If I log on console.log this, if I run it in the browser, right, so this is giving me Loki. It is working fine in the browser but not in Node.js. Why that's the case, I don't know. So this will be Loki, right? It will be Loki. Right here you can see hi from Loki. Now let's move on to the next question, that is question number 7. So cap dot say hi 10. So this one would be Steve, because we are calling cap2 dot say hi. This will be referring to the this currently calling object, and in inner arrow basically it's a function, so it will take the reference from the outer memory, that will be Loki. And yeah, so that will be Loki, Steve and Loki. In the Node.js it is showing some undefined value, but if you run it in the browser it will work just fine, like 52 Steve, 54 Loki. Let's move on to the next question, question number 8. So say hi is being called over cap3, so this will be Steve, and arrow function take the reference, take the this value from their outer lexical scope, so it will be again Steve, because this will refer to the currently calling object, so both will be Steve, right? Let's move on to the next question. Question number 9. So this will be Steve, that is pretty much clear. This will take the reference from its outer parent, that will be Steve again, and again it is the arrow function, so it will take the reference from its lexical scope, parent's lexical scope, so that will be Steve in all the 3 cases. Let's move on to 10th question. If you run in the browser, then it will work fine. Steve, Thanos, because they are anonymous function, they are not arrow function, so they will have their own this that will be pointing to window object, right? So window is having the first name as Thanos, so that is why this is coming up as Thanos. right? So this is the case. This is our 10th question. Now we have some interesting questions coming up. Question 11. Now suppose we are given no, we need to create an object such that if we call it like this, then they will give me such outputs. If we call the up method, then it will return me 1. If we call again the up method, then it will return me 2. And if we call the down method, then it will reduce the value by 1, and show step will give us the current value. And basically we can also chain the functions like this. So we need to define our object in such a form that will be showing us such outputs, and we can also chain up the functions. So how do we define that? So we need to maintain a count over here so that we can get the current value. So basically count will be this. Initially count will be 0, and up function will have, if when we calling the up function, then it should increase the count, and down function should decrease the count, right? And show step function should return the count. Now this much part is done. Now we want to chain it. How do we chain this? So in the functions we can do something like return this. Basically return the same object, returning the ladder object, return this, so that we can chain up the function. This dot count, this dot. Show step, okay, we cannot do it like this, we have to do it like this, right? Basically console.log, and right, so this will give us 4. So 1 2 3, so 3 will be the output, and if we hit down, then 2 will be the output. If we maintain it as it is, this is here is 1 2 3 4 and 3 will be the output, right? So we are done with the 11th question as well. So we are basically in up and down function we are returning this, so that we can chain up the object further, we can chain up the functions further, right? So next question is flattening an array. Flatten an array so function flatten array, basically we will be given an array like this 1 2 3 4 5 6 7, 8, and we need to print the basically let result equal to flatten array and console.log result. Basically we need to flatten the array, which means that we need to make all the values up to the one single level of array. So right, so we can do something like let result equal to a new array for let val of array if type of val is not equal to object, or maybe let's call it as if val instance of array, then we will do some operation, else we will do result dot push val, and ultimately we are going to return the result. Now what do we do when we are inside the nested array? So basically we will call up this function again and we will spread the values. Result dot push spread the values and call flatten array on the val, right? So basically it is gonna take up the recursion call and flatten all the values possible, and it will spread those in the results array, right? So we will get something like this. So what if we want to flatten the array based on the level? So what if we pass a level like this? Up to 2 level we want to flatten the array. So we can expect another argument level, and in the flatten array we can pass level -1, and level must be greater than 0. Then only call this, otherwise push the value. So we will get something like, so greater than 1, only 2 level, 1 and 2. I think we have to make it like this. Basically go 1 level and 2 level, and do not spread the value of, do not flatten the value of this array, simply take it as it is, right? So this is how we implement flattening an array. And how do we flatten an object? Let's move on to the next question that we will discuss next, right? So flatten an object function, flatten object, we will be getting an object, let result equal to empty object, for let key in basically it is, yeah, it is kind of flattening. So for let key in obj, if type of object key is not equal to object, then we will simply store it inside our result object. Otherwise we will flatten object on suppose we are having an object like this. Let obj equal to this, a is 1, b is 2, c d e 3 f 4. So we want something like obj to be a1 b2 c comma d comma e3 and c dot d dot f. So basically we are appending we are flattening the object by using the dot property. So what we can do is, for basically we will be getting an object and a parent key that will be empty initially, and the result object like empty object. So we will be iterating over the object let key in obj. If basically we will compute the new key first. New key will be, if parent key exists, then new key will be this, parent key dot key, and we will do this and ultimately return from it. So what we are doing is, if the object of key, so object of key object of a is not an object of c, obj of c is an object, so it will flatten this and it will pass the new key as parent key. Parent key was obj. Parent key will be c in this case. So parent key will be passed as the right. So this is how we flatten an object. So let me show you the output. Let flat obj console.log flat obj. Right, so this will be the output. Right, so this will be the output. Now next one is an interesting question. So question number 14. So we need to implement a function like this. Basically what does it do is it returns the number of times the function is called. So it is called only once, this is called twice. At the end we will be passing a 0 as an argument to end the function call. So what we can do is let count is 1. If a is 0, then simply return from it. Otherwise return function expect a b value. If b is 0, then return count, else return counter. And we will do count plus plus. Okay. I'm missing something here. There is some bug within this. Okay. Return function inner inner. I think we are good to go now. Yeah. So there was a bug in my code. So we are returning the same function again and again. If it is not 0, then we will return the same function again and again. Right? We have one more follow-up question for this. That is, we need to implement a sum function like this. So what we can do is, if not a, return 0, else return function inner b. If b is 0, then return a, otherwise return sum of a plus b. Again we are getting some error. If not b, then return, yeah, 178, yeah, right. So I think that I have covered a lot of questions. Next part will be sharing some more, around 7 to 8 more questions. So that's it, guys. That's it for this video. We will cover some more questions in the upcoming videos, right? So thank you for watching. That I have covered a lot of questions. Next part will be